Okay, so each tie on the railroad tracks is perpendicular to both the tracks here and here. What's the relationship between the two tracks? Okay, so there's this theorem called the perpendicular transversal theorem that says in a plane, if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other also. Now, the converse of this is essentially that if a line is perpendicular to two lines, then those two lines are parallel. It's the converse of this, okay? You're going from perpendicular to one line, and these two lines are parallel, therefore it's perpendicular to the other line. We're going to go in reverse and say if it's perpendicular to one and perpendicular to the other, then we can conclude that the lines are parallel. When you do the converse of these things, what you're essentially doing, these theorems say, assuming that these lines are parallel, then we know stuff, okay? And the converse of it is, if we know that stuff, perpendicular to this and it's perpendicular to this, we can go backwards to prove that the lines are parallel. A lot of these, the converse of them is proving that the lines are parallel when normally you need to know they're parallel in order to determine the other piece of information, okay? So I'm going to write then that the tracks are parallel by the converse of the perpendicular transversal theorem. Sound good? Okay, and the reason, again, is, and let me select all and change the color of this to make it pop a little bit better. Okay. If you're proving the lines parallel from the information, that's going to be the converse. Now, there's problem 25 in the next. Okay, so in this one, each sheet of metal on the roof is parallel to the rest of the sheets. So we are starting with their parallel. Oops. We're starting with their parallel, okay? And we say, if the first sheet of metal is perpendicular to the roof line, right here, then what can we conclude about the rest of the sheets of metal? Well, in this particular case now, then, we are just using the perpendicular transversal theorem, because that says if you've got lines that are parallel and there's some transversal line that's perpendicular to it, so here's the parallel lines, right, these sheets of metal, and the roof line is the transversal that is perpendicular to one of them, then we know that it's perpendicular to any other line that's parallel. Okay, so we can say, what can we conclude about the rest of the sheets of metal? We can say the sheets of metal are perpendicular to the roof line as well through the perpendicular transversal theorem. Okay? And again, just to clarify, when do we know that we're using the perpendicular transversal theorem and not the converse of it? Well, if we're told that the lines are parallel, and we are told that, okay, in this case the sheets of metal, then we're just going to use the theorem itself. If we're going backwards to prove the lines parallel from the information, then we use the converse. Okay, and finally, in number 26, it just says if C is perpendicular to B and A and C are parallel, what do we know about the relationship between A and B? Well, then they must be perpendicular as well. Okay, And look, that's exactly the perpendicular transversal theorem. That's what it says. So um, we can say then we know that A and, well, lines A and B are perpendicular as well through the perpendicular transversal theorem. Yep, because that's exactly what that theorem states. Yeah, hope that clarifies this theorem for you with those